At this point, a special shout out to Geo-Sustainable.
Hi folks, welcome back and thanks for joining. In my last video I announced EVs will never work. Hydrogen fuel cells will never work in their current format. So today we're going to start building a solar panel that will work. So we're going to rethink the solar panel, and we're going to take our cues from nature itself. The same way we took our cues from the bird to achieve flight, you might say. So we're going to see. Okay, so here's a standard solar panel. We've all seen them. They're all pretty much the same size. They all pretty much deliver the same amount of power. 200 watts in this much area. But today we're going to start building a solar panel that can achieve this much power in relatively this much space. And we're going to do it by design. And we're going to take our design cues from nature. So that's where we're going to start. So put on some good shoes. We got to head out to do this. All right. Join you there.
Here's where the big idea came from. This is algae, nature's best steward of sunlight. It does such a good job of collecting sunlight that none escapes. So this is the basis of our design right here. And we're going to explore the parts of the algae to understand a little bit better how to build this. And here's an artist's rendition of the structure that I showed you before. It's breaking down the diatom here. This is considered to be the complete frustal here. Epitheca, the hypotheca. And here is where the magic happens, where sunlight enters here. And it is processed, bounced around, and kept until it's all been used. And this is the cue that we're going to take from nature to construct our solar panel. And here we have a version. As you can see, the idea is not new. The folks at MIT put together this. This is the MIT solar cell, and it also is a much more efficient arrangement of solar cells in a small space, but they go up nearly a foot, I think. So, and the design is not optimized to its best. Here is something that could be considered a geodesic dome, and if you could imagine all the squares or any space that's large enough to hold one of the solar cells could hold the solar cell inside. And the cone that works best for this shape is a parabola, something like this, for use in the soccer ball shape. Which these were my initial designs here. We're going to be constructing an optimized axis concentrated reflecting solar panel. This is the cell configuration sheet here. The assembly detail is pretty much right here. So we're going to have cells standing up. We're going to have a cell on the bottom. We're going to have one cell on all four sides like this. And then we're going to have a transparent reflector that's going to be able to, reflect. The shape of it's going to help concentrate it, and the pyramid shape right there, it's going to give us an optimized axis for absorption. So this is what we're going to be building right here. This is the animal right here. So
hard to get. All right, time to prove it. So let's turn this guy on, set him to DC. And as you can see on my other camera, I have just one cell connected right now, the cell on the bottom. And the ones on the sides are not connected. Just wanted to show you where we're heading here. So the cell itself will generate about 5 volts. Let me show you a little bit here. So there it is. There's the positive and there's the negative for the cell on the bottom. I'm going to remove this reflector for just a moment. And show that guy in there, and we're at 568. This is just a light bulb, but that's probably what we're going to be able to expect. Now, when we put the reflector in, things change just a little bit. So, remember, I said this reflector only passes about 80%. The rest gets reflected, so we are. So something lower, okay? 4.5, 4.6, 2 volts in the ambient, it looks like. So now what I'm going to do though is I'm going to finish connecting this cell. So I'm going to go okay, so we're going to start right where we're going to start. Bottom. Okay, positive, negative. Okay. Just this. Okay, positive, and then we're going to grab negative here. And I'm connecting this up in series because it's the easiest way to see for you folks to see the increase. And I'm just going around and connecting in series all the positive and negatives all in a string. Okay. Negative to positive. And that should leave me negative. All right. So we have positive. Oh. Okay, so in ambient we're at 13.5 volts. So it's easy to just do it like this, I think. So we have 27, 24, hitting all the angles. So 24, that's good. Just 25. So it's all, everything is reflecting rather nicely. And we have 27. And last night I got 30. So it'll change depending on how good your connections are. So there we have it. And in ambient light, we're still doing 11 volts. So what we've done is simply we've increased the number of cells in a particular surface. in a particular space right here. So instead of just laying everything flat and letting it go, we have optimized here, and we've built a cube to mimic the algae, so that when the sunlight comes in, it's going to reflect off of that reflector, and it's going to hit the sides of these solar cells, and it's also going to pass through and hit that one on the bottom. Now you'll remember I showed you this guy right here, but there's only 4. And when I saw the reflective film and saw that it was transparent, that's what gave me the idea to go ahead and then add the 5th cell. Now this is not the only shape that can be done to gather this. There's a lot of ideas. You can make a big one, a circle, make one the shape of a soccer ball. As long as you have that aperture, I think a soccer ball shape with a parabolic curve reflector. That was my original design, which is optimum. So that way we had a parabolic coming in, and light would shine down on the parabola and concentrate it, shine it on cells that were on the bottom and on the top of the soccer ball shape. So the geodesic dome. So that's optimum. All right. There's proof right there for you folks. I want to make an observation, and that is I'm not the first guy to do something like this, is to make a solar panel for his EV. There's a couple other fellas on YouTube that have done it. One guy in particular, he has a Tesla, and he actually bolted one of these on the top of his Tesla. And then he eventually put 4 more of these in the trunk, and then he was able to pull them out. And that's how he charged his Tesla while it was sitting still. And I think in the very end, he added 2 more to the top where they pulled out like on an RV. And a fellow did a series of 12 videos on this thing, this monster. And he got 500,000 views each. Now, there's a company out there that watched his video, I think, because they also made a solar panel more form-fitting to the roof of a Tesla. But they also included 4 more in the trunk. And I'm expecting using this much area per panel. So the options, and even Tesla has gotten in on it. They have actually put solar panels on the hood, I think. The hood, and at the end of this, I'm hoping that you'll see that this idea right here is far superior to what anybody else is doing. And if it is, we'll pass this along. I just wanted to point out the ridiculousness of some of the ideas. I'm the same age as Steve Jobs, and when we were younger, we ran in the same circles, although we never met. But back then, elegance was part of design. So this is going to be elegant, and as you can see, it kind of already is. So here's the big idea right there. So there's 5 solar panels and a reflector in there, and we're going to put a whole bunch of these together, and we're going to generate some serious power. This cube already equals the voltage of this entire panel. I hope you made it to the end of this, and if you have, great. We're going to continue building these, and we're going to start mounting them onto a plane that we can use to mount onto our car itself. So those are in the next videos down the line, so stay tuned, and thank you so much for watching. Bye-bye now. Take care.